Welcome to the Fuel Pulse Show podcast. I am your host, Erik Bjornstad, and I am your guide through the ever-changing world of fuel. This podcast is for everyone who may have a job where they use or manage fuel in some way, or they work with and manage things that use fuel, like fleet vehicles or equipment. Plus, it's also for everyone else at home that has things that use fuel, drivers, people who have lawnmowers, small equipment, home generators. So the Fuel Pulse Show podcast is for pretty much everyone. So what are we going to talk about today? If you have to manage stored fuel in a professional capacity, then at least some of you out there have to have that fuel tested on at least an annual basis. Now, not everyone in this position has to have the same kind of test done on their fuel. Which tests are required often will depend on what's most important for the given situation where the fuel's used. And many of these fuel tests are needed to establish if the fuel is still in specification. Now, what do we mean when we say that, in specification or in spec? What we mean is if the fuel is still in specification, then you can safely assume that it will perform adequately in the engine or equipment that you're going to use it in. And at this point, we have to point out that since we mentioned the importance of verifying that the fuel is still in specification, still, when we say still, that implies that it is possible for the fuel to change so that it may be out of specification. Now, what are the consequences to having out of specification fuel? Well, that is one of the things that we're going to talk about today. Testing, this kind of fuel testing that we're referencing, testing will tell you about the properties of the fuel. But that may raise the question, what is the worst that can happen if you use fuel that happens to be out of spec? So that's another question that we're going to talk about today. Now, in terms of the fuel being in specification or in spec, when we consider that, we focus primarily on the list of properties, the list of things covered under ASTM D975, which is also known as the standard specification for diesel fuel oils. Standard specification means that it essentially defines what diesel fuel is. And we are primarily in this episode going to be sticking to talking about diesel fuel, not gasoline, because diesel fuel is by far the most widely used by business, and it's the most commonly stored of the major fuels. Now, D975 covers multiple grades of diesel fuel oils, 7 in fact. The first 3 are what they call grade 1, S15, S500, and S5000. The S, you might have figured out, relates to the sulfur content. That means the first 3 grades are grade 1, 15 ppm sulfur, otherwise known as ultra-low sulfur grade 1 or kerosene. The S2 is 500 parts per million, S3 is 5,000 parts per million. So those are the first 3 grades covered under D975. The next 3 grades are grade 2, S15, S500, and S5000. And then there's a final grade covered by D975, which is grade 4. Now, for our purposes, and probably for your purposes out there listening in the audience, we're most concerned with the S15 grades because S15, as I said a moment ago, is ultra-low sulfur diesel, the kind which is pretty much the ubiquitous law of the land, so to speak. So it's good to point out here that with D975, when we said that it defined the specifications for diesel fuel, we mean that in order for something to be legally defined as diesel fuel, it has to meet all those minimum requirements laid out in D975. But that raises a little bit of a philosophical question, which is if a particular fuel falls out of spec in some way, does that mean that it ceases to become diesel fuel? As I said, that's a little bit of a philosophical question, but from a legal standpoint, the actual answer is yes, it does. Now, you might still call it out of spec diesel because at one time it was in spec diesel, now it's out of spec. But legally, that thing in and of itself is still not diesel fuel anymore because the legal definition of diesel fuel is it's something that meets the specifications listed in D975. And so talking about all that feeds into recognizing that there is a purpose to having these kind of property definitions, a purpose to saying that diesel fuel has to meet these requirements. And that purpose is so that you, as the user, can have confidence that the fuel is going to work like it's supposed to. It's going to work like you're expecting it to. And when one or more of these essential properties is off, then the potential is created for the causing of real problems in the engines that you're going to use the fuel in. And that's whether you use the fuel now or maybe sometime in the future. So that's what we're going to talk about on today's episode, because it's one thing to have your fuel tested and get a test result back that says, for instance, the diesel fuel in your fuel tank has a flash point that's too low. So you've got a problem there. But it's also good to know, could be even important to know what the consequences or what the effects might be when your stored fuel comes back with a bad test result in a certain area. I mean, not all of these, red flags are created equal. Is the particular one you're looking at, is it serious or not? Well, that's something to consider. So at the very least, knowing that kind of information, knowing the meaning of an abnormal fuel test result, that can be useful to help inform or help you decide what kind of action you might need to take. And so, over the course of this and some of the coming podcast episodes, what we're going to do is we are going to look at the 11 fuel specifications that comprise Table 1 of D975, the detailed requirements for diesel fuel oils. And if we have time, we may throw in a couple of additional fuel properties at the end that we think are also important, but which may not be contained in the actual D975 slate of property specifications for diesel fuel. So to kick this series off, we are going to start at the top of the list of that Table 1 in D975. And that means we are going to start off talking about this thing called flash point, the flash point specification for diesel fuel. Now, flash point is defined as the lowest liquid temperature at which a liquid gives off vapors sufficient enough to be capable to form an ignitable vapor-air mixture. Now, we say liquid and we say vapors because, contrary to what it looks like with our naked eye, so to speak, things do not burn when they're in solid form. They burn, actually, when they're in gas form. So think about it this way. You have a campfire going and you take a log and you put it on the fire and the log catches fire. And so when you look at it, it looks like the solid fuel is burning, right? But even a solid like wood, even a solid only burns when it actually gets hot enough for the solid material on the very surface of that log to vaporize and turn into a gas. Once that happens, that is actually the thing that burns very quickly. And so when you put that log on the fire and you watched it burn, that is what was happening to that solid log. You put it into a very hot fire, which has a really high temperature, and it essentially superheated the material in that log in a split second. And that solid material on the outside of the log essentially turned into a liquid first and then into a vapor in literally a split second. And then that vapor then mixed with the available oxygen that's in the air surrounding that. And because of the latent heat in its environment, it ignited and it burned. And all of this entire process happens literally in a split second because there was plenty enough heat in that campfire to superheat that log really quickly. And so the solid log burns and you get to make s'mores or something. So flash point then is the lowest temperature at which enough vapors are given off that the liquid in question can burn. It can form an ignitable mixture with the air enough that it will catch fire and burn. Now, if you're below the flash point temperature, then practically speaking, things don't burn below the flash point temperature. I mean, you certainly don't need to worry about a given liquid suddenly catching fire at a temperature below its flash point. But what happens if you put a flame by it? You have one of those charcoal lighting sticks and you turn it on and you stick that flame by the thing of lighter fluid that you have. Well, if you put a flame by it, well, now things are different because you have now introduced something additional that's going to change the temperature. So let's say that you have a solvent that has a flash point of, let's say, 60 degrees Fahrenheit. And let's say that you have that solvent outside, and the temperature outside is, it's the fall, so it's 45 degrees Fahrenheit. So just in and of itself, you have no worries about that solvent igniting, no worries about ignition there. But for whatever reason, whether you're careless or you're just stupid or something, you take a flame and you stick the flame near the liquid, and the flame causes the liquid to catch fire. Well, what happened? I mean, the ambient temperature was below the flash point, right? Well, what happened was the flame that you introduced, it heated the air and the surface of the liquid above that 60-degree flash point. So now it can catch fire. But in order for that to happen, you needed to introduce an ignition source, and you needed to place that ignition source in close enough proximity for all of that to happen. Now, flash point is also not to be confused with a couple other reference temperatures. There's the auto ignition temperature. Auto ignition temperature is the temperature that causes what they call spontaneous ignition. In other words, it spontaneously ignites in a normal atmosphere that has oxygen, but you didn't need a flame for it to do so. Auto ignition temperature is always going to be significantly higher than the flash point temperature. For example, charcoal lighter fluid, right? Charcoal lighter fluid gives off enough vapors to ignite at around 160 degrees Fahrenheit. So that is its flash point. But the auto ignition temperature for charcoal lighter fluid is 500 degrees Fahrenheit. And that means it's going to be really easy to start a charcoal grill on, let's say, the planet Venus, where the temperature may be around 900 degrees Fahrenheit. Though, to be fair, the atmosphere on Venus is mostly carbon dioxide with sulfuric acid. So it would actually be a lot more difficult than one might think to keep that Venus fire going. So that's auto ignition temperature. Another temperature you might have heard reference is called the fire point. The fire point is the lowest temperature at which the vapors that have been formed, the lowest temperature at which those vapors will continue to burn after the ignition source is removed. So go back to that campfire. You put something like a log into that campfire. Not only is the log going to superheat instantaneously above its flash point, but it's also going to soar above the fire point. And that is why the log is going to keep burning, because all that heat energy there, all the heat energy that's already there, combined with all the additional heat energy that's formed by all the exothermic, heat forming combustion reactions from the carbon in the log, all of those are going to keep the fire's immediate temperature way above the fuel or the log's fire point temperature, which for the wood is going to be about 700 degrees. And so that is why that fire can essentially keep on going of its own volition, because it's above the fire point temperature for the fuel that's in it. So going back to D975 and that concept of flashpoint, how do they determine the flashpoint temperature of something like diesel fuel? One of the things that D975 does is, besides listing the property name and the result that it should be, flashpoint X. Beyond doing that, they also give the identification of the test that should be used to determine or measure that property. And that makes sense because taking a step back and looking at the situation generally, if any of the information in D975 is intended to be used as a reference by different parties, then it needs to be defined what test has to be used to determine that result so that everyone is on the same page about how to measure the property itself. So to give you an idea of how they do this for Flashpoint, there are a couple of different Flashpoint tests that can be run. One of the, shall we say, most popular ones is called the closed cup test. So you need at least 75 milliliters of liquid required to run this test. You put that liquid in this closed cup apparatus, and the sample liquid in the cup is stirred and it's heated at a slow, constant rate. And at certain intervals, they will open the lid to the cup and they will take an ignition source, a flame, and they will move the flame over the top of the cup. And the flash point is the lowest temperature or the first temperature they reach, at which the application of that ignition source causes the vapors above the liquid to ignite. That is one way that they measure flash point. Now, since we are talking about diesel fuel, a fuel that's burned inside of an internal combustion engine, flash point does seem like an important characteristic. You do not want the flash point of that fuel to be too low, because if it's too low, it has the chance of igniting too quickly in a diesel engine. You also do not want it excessively high, or it may not ignite fast enough. Both of those situations, a flash point that's off in, let's say, either direction from the ideal, both of those situations could result in performance issues for the engine if the deviation, so to speak, is wide enough on either side. Now, that leads us to the question, what should the flash point for your stored diesel fuel, what is it supposed to be? Well, D975 lists the flash point for number 2 diesel, and doesn't matter if it's S15, S500, or S5000, it's all the same. For number 2 diesel, the flash point is supposed to be a minimum of 38 degrees centigrade or 100 degrees Fahrenheit. Now, it's also the same for kerosene. Both of those, kerosene being number 1, both of them, the flash point has to be a minimum of 100 degrees Fahrenheit. In other words, it has to be above 100 degrees Fahrenheit. It cannot be below. And there are other petroleum fuels that have significantly different flash points. And that's going to matter for reasons that we will see in a minute. But for diesel, it's supposed to be around 100 degrees Fahrenheit. Now, gasoline has a significantly different flash point. The flash point of gasoline is supposed to be around minus 40 degrees Fahrenheit. That's like at least 140 degrees lower than the flash point of diesel fuel. And that means gasoline can ignite with an ignition source in just about any terrestrial earthly environment. Doesn't matter if you're in the winter in Detroit or you're in the summer during Carnival in Rio de Janeiro. Gasoline can ignite in just about any temperature environment on Earth. Now, so that's gasoline. Take an organic solvent like acetone. The flash point of acetone is about minus 4 degrees Fahrenheit. The flash point of ethanol and methanol, both of those are simple alcohols and also happen to be common additives to gasoline. Their flash points are around 55 and 50 degrees Fahrenheit. So, flash point of diesel is supposed to be at least 100 degrees Fahrenheit. So what does it mean when you get your stored diesel fuel and you test it, and then you get that test result back and it shows that the flash point is too low. It's out of spec. Because remember, D975 defines the properties that diesel fuel oil should have, and D975 says that it has to be above 100 degrees Fahrenheit. Well, now it isn't. That means at least one of your diesel's properties doesn't meet the D975 requirement. And so we have three things that we have to consider when we're faced with this situation. The first thing is, what possibly could have caused that to happen? Then the second thing is, what if you choose to use the diesel fuel anyway? What negative effects, if any, might you expect to have? And then the third one, which is probably the most important one in the end, which is, what should you do about it? How can you fix that problem? Can you fix it easily, or is it a more difficult fix? Well, let's consider those questions. So for the first question, how did this happen? For that first question, the possible cause of a low flash measurement in your diesel fuel, that's actually a fairly simple question to answer, because flash point is not a property that simply changes on its own. It doesn't change appreciably in response to other things happening in the fuel, like, let's say, oxidation or microbial attack. Those things don't really affect flash point very much at all. Instead, low flash point is virtually always caused by contamination with another substance that happens to have a lower flash point temperature than the diesel fuel is. Now, thinking about what kinds of fuel are commonly used that have flash points significantly lower than diesel, well, the first one that comes to mind is actually the most obvious answer, and that is gasoline. There's a huge potential for inadvertent contamination of diesel fuel with gasoline. Like, for example, you have what they call these switch loading situations, where a fuel delivery of gasoline will be made, and then they're going to take the same truck with the same tank, and they're going to use it later to deliver some diesel fuel. But in between making the gasoline drop and then loading up with diesel, they're supposed to clean it out, but they don't always get all of the gasoline. So maybe they accidentally leave a small amount of gasoline in there, and that small amount mixes with the diesel fuel, and it ends up depressing the flash point temperature of what is now essentially a fuel blend. And it really doesn't take much gasoline at all to have a meaningful effect. Remember, the flash point of gasoline is around minus 40 Fahrenheit, so it's well below zero. And the flash point of diesel is, as we've said, about 100 degrees Fahrenheit. Now, Chevron reports that just 1% or less gasoline mixed into diesel will lower the flash point of that diesel fuel below the specification minimum. Or put it another way, take 1% gasoline contamination can lower the flash point of diesel fuel by 18 degrees centigrade, which means, let's say you start at 110, your diesel has a flash point of 110, and you accidentally get a tiny amount, 1% gasoline. Well, it's going to lower that flash point down to below 80 degrees, and now it's definitely out of spec. If you happen to get more gasoline in there, let's say up to 5%, it can drop it down as much as like 90 degrees. So now the flash point of your diesel, it's not 110 anymore, it's more like 0. So the most common explanation for how you can get into a low flash situation for your diesel fuel is that your diesel fuel was contaminated with some volume of a lower flash item, most likely gasoline. So, second question, what happens if you don't do anything about it? You decide to use that low flash diesel fuel. Now, remember earlier we said that if the flash point was too low, then the fuel could prematurely ignite in the engine, and that could give you various performance problems. Now, whether that's actually a huge concern in practice depends on how low the flash point is. Is it a little too low, or is it a lot too low? And that's not something that we can really advise you on what to do right here. whether you should do that or not. So us talking about this is not telling you or recommending for you to go ahead and use some diesel fuel where your flashpoint came back as being out of spec. Our official position would be to always use in spec fuel. But just speaking from a practical standpoint, the chances of a major engine problem increase the lower the flashpoint is. Excuse me. But the biggest concern with a low flash diesel situation is not necessarily the engine performance. It's the safety of handling for that fuel. The lower the flashpoint is, the greater the risk for explosion hazards as that fuel is being handled and transported. If you have let's say, a larger gasoline contamination where the flash point of that diesel has been reduced down close to, let's say, 0, now you have a really hazardous handling situation. So that's the biggest risk for low flash point. And so that brings us to the third question: what to do about a low flash measurement. Now, it would be, shall we say, cheapest if you could simply find something that you could add to the fuel and it would raise the flash point back up to the back above specification where it's supposed to be. And theoretically, there are things out there that could do that. But there's a problem though. The problem is that even if you can do that, whatever you decide to add is it's highly likely to adversely affect the properties of that diesel in a different area. Almost like you'd be solving one flashpoint problem, but creating a parallel problem in a parallel area somewhere else. And the only way to know if you had solved the flash problem without causing another problem would be to run another D975 test slate and look at those fuel specification properties again. And now you're getting into the area where the cost of doing all of that might outstrip any savings you think that you were achieving by using, the so-called simple solution of just adding something additional to the fuel. So the best course of action to solve this problem is going to be simply to recycle the gasoline contaminated diesel back to your supplier, or have them replace it if you think it's their fault. Essentially, you're going to have to dump that fuel and you're going to have to replace it with fresh in-spec diesel fuel. And that's not what most people want to hear, because when you tell them that they have to do that, sometimes they feel like they're wasting something that they paid for. And if you really believe that the contamination is the fault of your supplier, you should definitely take it up with them. But unfortunately, there's no easy drop in and go solution for this problem. You're going to need to replace that fuel. Some people have suggested, they'll say that they can correct the problem just by diluting it by adding more diesel fuel to the blend, because of course diesel fuel has a higher flash point than gasoline. However, for most situations, that's not really going to solve the problem, because of the simple fact that the amount of additional diesel that they're going to need to raise that flash point back up to where it's supposed to be is going to be impractically large. If you're one of those people that decides that this is the route that you want to go, then what you definitely will want to do is, after you have diluted it to where you think it needs to be, you're going to need to have that blend checked by a laboratory in order to make sure that it meets specifications. And so that, my friends, is what to do about having an out of specification diesel fuel flashpoint test. And so that is all for today's episode of the Fuel Pulse Show podcast. You can find information on everything that we talked about in the show notes for this episode. We ask, if you haven't already, feel free to subscribe to the Fuel Pulse Show podcast at your favorite podcast platform, whether that's iTunes or Stitcher, Amazon Podcast. Whatever's your favorite, subscribe to it. It would also be really helpful if you could leave us a rating, as positive ratings really do go a long way to helping people find us. So again, thank you for joining us for today's episode. I am your host, Erik Bjornstad, And I will see you next time on the Fuel Pulse Show podcast.